So let's quickly go through what we've done with matrices now. So if I have let's say A at 1 being 1's 2 by 3, so mat 1 plus 3, add 3 to everything, mat 1 times 15 14, multiply everything by 14, mat 1 minus, let's say, mat 2 magic 3 by 3. So mat 1 minus mat 2, subtract incompatible sizes. Okay, this is a 3 by 3. Okay, yeah. Alright, so let's have mat 2 being random 2 by 3. Nope, that's not 2 by 3. Okay, see what I do. Let this be 12 and let this be size. So mat 1 minus mat 2, subtract everything in mat 2 from mat 1. Mat 1 dot times mat 1 dot times mat 2, multiply everything in mat 2 by 1. So if we wanted to perform let's say matrix multiplication now, mat 1 has 3 columns, mat 2 has 2 rows. We will need mat 2 to have 3 rows in order for matrix multiplication to occur. So we could transpose this and then you have the multiplication happen successfully, right? Alright, let's now look at the transpose function and a few other functions that we use in MATLAB on matrices. So we have the transpose. I've already introduced shown you the transpose. So transpose is also a function of its own. Help transpose. So the transpose does the same thing as the adding an apostrophe. Transpose a vector or a matrix. This MATLAB function returns the non-conjugate transpose of A, that interchanges the row and column index for each element. So if B, so this means that we've already seen it, but let me just show you. So mat 1, mat 2. So this is mat 2. Nope, this is not mat 2. Right, so this is mat 2. So to transpose this, we could just add an apostrophe or use the transpose mat 2. Add the same thing. Right, so it just interchanges. The first column becomes the first row, second column becomes the second row, third column becomes the third row. Okay, so rows and columns are interchanged. If you transpose a column vector, it becomes a row vector becomes column vector. Okay. Then we have the determinant. So to find the determinant of a matrix, we use the DET function. So the DET matrix determinant. This MATLAB function returns the determinant of a square matrix A. So let's get a matrix, square matrix, and then get the determinant of this matrix. Right. So the DET is used for finding the determinant. We can find the inverse of a matrix using the INV function. The INV gets the determinant of your square matrix as well. Then we also have norm. So norm gives you the So let's just see what help says. Excuse me. Is a non-Euclidean length. So vector and matrix norms. But this MATLAB function returns the Euclidean. Okay, the Euclidean norm of vector v. So if you had in vector v, let's say 3 and 4, the square root of 3 squared plus 4 squared is 5. So norm v will give you that 5. If you had v is 5 and 12, it will be 13. But if you had even longer vectors, it gives you the Euclidean length of that. Okay, that's no. Right, so the last thing we're going to do is find, we're going to solve a simple system of equations. I've written it out here. So we have two simultaneous equations here. We're looking for x and y. So we would solve this using the sort of the way you would use Cramer's rule, right? So you'd first of all put this in matrix form, put in the coefficients in a matrix on its own, and then the unknowns will be their own matrix, and then the outputs, the results, sorry, will be in their own matrix. So here, in the first equation, you have 3, you have minus 2 as the coefficients of x and y. Bottom equation, you have 1 and 4 as the coefficients of x and y. And then you have 5 and 10 as the result of the outputs. So the coefficients, let me call it coefficient matrix, will be 3 and minus 4, and then the bottom we would have 1 and 4. I think that's correct. Let me check. Okay, 3 and minus 2, 1 and 4. 3 and minus 2, 1 and 4. Right. What is your coefficients? Then your unknowns will be x. So then your outputs or results 5 and 6. Right. So the way it is you have your coefficients multiplying your your unknowns be equal to your results. Now if you want x, you divide both sides by the coefficient matrix. So it will look like x now is equal to res divided by coefficient max. And this is going to evaluate coefficient dimensions must agree. Number of columns must be equal to number of rows. What is the issue? No. Okay, sorry. Incorrect dimensions for matrix multiplication. Okay, sorry, my mistake. For to solve this, what you need to do is your res divided by coef max. Right, this is equivalent to the inverse of coef max multiplied by res. So this is what we're going to do. And our x is going to be 2.2857 and our y will be 0.9828. So let me see. Let's confirm this. 3 times x minus 2 times y. 3 times x minus, because x is up and y is down, 2 times y. 5. Right. Then down here, x plus 4 times y should be 11. X plus 4 times y should be 6. Alright, we have 6 instead of 11 here because I made a mistake. I put the outputs 5 and 6, not 5 and 11. So, but still we have a 6, which is the correct answer. So let's try it again with 5 and 6. Let's say 5 and 11. Right. So x will be inverse times coefficient of this x and y. Dimensions incorrectly. Okay, sorry. Res should be a column vector. Then we run this again, and this will now give me x and y is 3 and 2. Right, so x will be this, and then y will be this. So now to confirm, 3 times x minus 2 times y, 3 times x minus 2 times y give me 5, and 4 x plus 4 times y, x plus 4 times y be 11. Right, so we solved that. Okay, so thank you very much. So you can solve simultaneous equations using like just Cramer's rule. So you just do it very simply using the MATLAB functions, multiplication and the inverse function. Right.